Okay, the extension question. With questions like this, we're really getting into the realms of the grade 9 type questions. However, having said that, that doesn't mean if you don't think you're going to get a grade 9 that you shouldn't pay attention. You absolutely should, because even if you weren't able to, in the end in the exam, to get all the marks on it, you should try to interpret the question, and you may well get some of the marks, which may lead you to get that grade 8 or grade 7 that you really are targeting. So everyone needs to pay really good attention to this. Right. The area of a parallelogram is 15 centimeters correct to the nearest integer. The shortest side of the parallelogram is 4.5 centimeters correct to two significant figures. The longest side of the parallelogram is 7.1 centimeters correct to two significant figures. Find the largest possible size of the two acute angles in the parallelogram. Give your answer correct to 3 decimal places. So the first thing is, it's very wordy, and it's going to help me to draw a diagram. And that's a general good idea for for a tricky problem-solving type question. So here we go. I'm going to just draw out a parallelogram. Make it a bit bigger. It doesn't have to be super accurate at all. Okay, just a general sketch. So the shortest side is 4.5 centimeters correct to two significant figures. So what that means is this side here and the corresponding opposite side, so this side here, is somewhere between 4.45 and 4.55 centimeters. And the longer side is somewhere between 7.05 to 7.15 centimeters. And right there, you've probably got yourself a mark in the exam. In fact, I would think you definitely do have yourself a mark straight away. Okay, so just from doing that. Right, the next bit, I'm going to add in my height of the parallelogram, because I know, because if I'm given the area of the parallelogram, then I know that area for a parallelogram is equal to just the base times by the height. Now I'm trying to maximize this angle here, right, and the other one, but they're going to always be the same as each other in a parallelogram. So I'm trying to maximize that angle. So the key realization is that the closer this gets to being a square, right, it's going to tend towards a 90-degree angle for the acute angle. When it's a square, you've just got all angles at 90 degrees, and that would be the most, right? And so as it gets closer to being a square, then it will become as big as this angle could possibly be. So if we think about that, it would be close to being a square if the height was long. You might think about it, if the height isn't very long here, if the height is basically the same as the width, if the height's the same as the width, then it is a square. If the height's close to the same as the width, then it's getting close to a square. So we want the maximum height, and that I think is a key realization. That I want to generate maximum height. So I'm going to rewrite this formula. So the area divided by the base is equal to the height, and I want maximum height. Okay. So maximum height is equal to, right, how am I going to get the biggest height from my different numbers for the area and the base depending on the nearest, to the nearest to the correct degree of accuracy. So the area is 15 centimeters to the nearest integer. So to get the maximum height, I'd want the most area and divide it by the smallest base. That will give me my maximum height here. And I know my height needs to be maximum because this is my longer side, so it needs to be stretched out as much as it possibly can towards being a square. So the most area that I'm going to have is 15.5, and the least base that I'm going to have is 7.05. So that gives me my maximum height. I'm just going to put that into the calculator. 15.5 divided by 7.05. Okay. I've got this long decimal, but I've also got it as just 310 over 141, which is perhaps easier to use. So that's my maximum height, that in centimeters. Okay. So let's kind of zoom in on this triangle here. I'm going to draw this triangle out just a bit here below. And I know now what this height is, right? What my height here is, which is this bit. 310 over 141 centimeters. Okay. And I'm trying to make this as big as possible. I've also got this side. It's this bit here. Somewhere at 4.45 to 4.55. Now, what is the length here that's going to make this kind of closest to being essentially just straight? Because if it's straight like this, then we've got a square. Right? If it's straight up like that, we've got straight. So this, as this comes in, this angle will get bigger, right? As this hypotenuse gets smaller, this will get bigger. So I want the smallest possible length of this. Imagine it, if it was really long, then the angle would be small. If the hypotenuse was really long, the angle would be less. So I want the smallest possible one here, which is 4.45. Okay. And now I've got my angle, we'll call it theta. I'm just going to zoom out a little bit. I've got my angle there, and I've got the opposite side. I can label that up. And I've got the hypotenuse. So I'm going to use my trigonometry, right angle triangle, likely to use trig. So I've got sine of the angle, sine theta, equals my opposite, which is 310 over 141. Over hypotenuse, which is 4.45. In this case, if I'm going to maximize the size of the angle. Okay. And so to find theta itself, I'm going to use the inverse sine of all of that, 310 over 141 divided by 4.45. I can actually put this entirely into my calculator like that to find the angle I need. So that's what I'm going to do. Theta equals sine minus 1. Okay, let's set this up. So I'm going to have a fraction, and then I'm going to have a fraction within a fraction. And that gives me 310 over 141. And that's... That's being divided by 4.45, and that gives me 29.608 degrees. To 3 decimal places, 29.608 degrees. And that is that.